Okay, so now I guess everyone can hear my sound. Hello, I am One Punch. So today, what I want to share about is how to debug V8 in GDB. So I think someone who know about or interested in browser exploitation will be familiar with this topic because they will know that we can debug JavaScript file in GDB. So isn't it powerful? Okay, so now I will show how to debug the JavaScript file in our GDB. First, I will talk about why we need to debug JavaScript file in GDB. For browser exploitation, we will need to do something like binary exploitation. For binary exploitation, what is important part is that we need to familiar with the memory structure. We always can use the GDB to take a view of the memory structure. So how to debug the JavaScript with GDB become a very important issue. So this is also what I have recently spent a quick time to handle with. So first, what I want to debug or the JavaScript file in this video is this file. Here, the first line you can see here is an object which is called A. In object here is one small integer, here is one double integer, and here is one string. And at the second line, here is a native function call of a native function call of the V8 engine. So I will show this for my example of native function. If you use this native function in V8, you can print out the memory structure of the parameter. So how do we print out such things in this web page? I will show in my terminal. Second line, so here you can see in my JavaScript file, in the second line, I debug print out my object on the first line. And the last line, the list thing, don't worry, I will talk about it later. Now we try to use our V8 engine to run the JavaScript file and test out what we will take a view in the terminal. So this is my V8 execution file, which is called D8 in the path of it. And the parameter would be the file, the JavaScript file I want to run down. And be careful, if you want to use just like this kind of native function which has the percent symbol at the start place, you need to add a comment option which is called allowed natives syntax. Okay, so now you should see the similar result in the terminal. Okay, here we see the result of debug print is the parameter of the object A. I will show again what is in the JavaScript file. So when I print out the A, the first print out result is these things. I can guess that would be something like memory address, and in it there is still a map, prototype, elements, length, properties. So these things may store in the memory structure, and with the native function which is called debug print, we can see what is in the memory. Now look at the element parts. This is very important, which can always help us to find the elements. So in this element, there are 3 elements, which points to the 0 part point to our list part, the first index. The second part point to our second index, and the third part point to our string. So now we can see the full memory structure with the native function. However, native function cannot always work very well when we want to debug. Sometimes we just want to make a breakpoint in the maybe middle place of the JavaScript file, and then we want to continue on to work on the JavaScript file to see what happened to the previous object or previous array. So how do we set up a breakpoint of V8? This is a very I cannot say very difficult, but I spent a quick time on it to solve the problem. So how do we use GDB to debug JavaScript file? First, I will use GDB. Let me see my GDB. Okay. So first, we need to use GDB and with some execution file, right? So of course, our execution file may be the V8 execution file. So when we try to see what is in the main function, oh, wait a minute. Oh, I find something wrong because the 8 execution file is not in this path. So wait a minute, sorry. Okay, D8 is in this file. So now we can use GDB to debug it. To see what is in the main function, I used a command of GDB which is called disassemble. Here we can see that someone opened up the V8 shell main function. Here we can go into what is in the D8. So now if we try to run up, and we can get into the shell of the V8. Just try something like hello world. Okay, so this is work of the V8 JavaScript engine in the GDB. Okay, so now we will try to debug our file which we have just talked about, which this one. We will use GDB to debug this file. Of course, we will run it and add our command option and add our file name. Okay, so here you might know that the first place I use GDB to try to debug the V8 JavaScript engine, and here I add the JavaScript file as the option to run up. So this means that I debug this JavaScript file with my GDB. So now we can see what happened will be. Okay, so this really makes sense, right? We just again run up the testgdb.javascript file with our V8 engine in GDB, and it of course it will just run up with the same result and then X process. But I just want to make a breakpoint in the middle place of the JavaScript file. So this really this really make a big difficult problem, and my brain is near to explode because I cannot handle with this problem. Not until I see someone use the math function as the breakpoint, which will not make any interrupt to the terminal. So what I'm talking about is this math function of cosine h. So just like maybe of course I will show in the code. Here. So just like this kind of function or tangent or maybe sine, this kind of math function, some people say this kind of function is really good to work as the breakpoint, because not like print function, the print function will print something to standard output, and we also need to maybe redirect the output to the other place to make it not to interrupt our own work. It will just help us to give a math problem just like I gave here, a math cosine h1, and he just calculate and not even print out the results. So this is the, if I can find the file in the V8 engine, I can set the breakpoint at there, and it will work as the breakpoint in our GDB. So how to find the breakpoint of the math function? I just use this, just like I have showed in the project of Chromium. I use search this function, and it just shows that it will be called in this file in V8 project of SRC base folder in the file of IEEE 754. So now I can just set the breakpoint at here and use it as a breakpoint in the GDB. So how do I work it? I will demo it. So first, okay, with this first result we run in GDB, I am trying to look into the memory structure of these elements. But, but when I try to look into the memory structure or printout address, I cannot access anymore because the process has already not running. The process has already existed. So now I need to set up a breakpoint to make it start before the V8 existed. And I have said that I use the math function as the breakpoint. So now what I going to do is set up the math function as the break point in GDB. So here I will start to set up a breakpoint. However, how do I set a breakpoint? It is another issue. So let us go back to see again what is in the main function. I gave my thoughts of setting how to set the way about how to set up a breakpoint come from this way. We can set a breakpoint just on such things function v8 the namespace under the shell and the namespace under the global v8. So what I can set up the breakpoint about the math function, I just need to go to see the namespace in the project code. So here I would like to go to find the top namespace. The top namespace is v8. This just makes sense, right? And the second one namespace is base. And the third one is IEEE 754. So in these 3 layers of namespace, we just can go to find our cosine function. Maybe this is a little complex, but I can show you what I just mean. To set up the breakpoint of cosine h, I just need to give a breakpoint just like v8 base IEEE 754, and the last one is the function just like this one, my function. Okay. So here we can find that the breakpoint has already set up. To see the information of breakpoint, we can use info breakpoint, and it is show that I have set up the breakpoint at this address in this file. So I guess it is the right place. Now we can start to run this file. So what I expect to see on the monitor now, I expect to see that the process will not exist, and I want to see the result of the debug print. And then I just can access the memory of this debug print memory address. So now we just need to run up again the JavaScript file. Nice. Now we can find that the process didn't exist because it just hit our breakpoint of the cosine, math cosine. But I still cannot see the result of the debug print. What happened? It is because that the result of the GDB has already print over the whole monitor, so we cannot even see the result of the debug print. So this is another problem I need to handle with. How to show the result of debug print in GDB. And even I have set up a breakpoint. Okay, so this is finally I have find out a very interesting method to set up the to show the result of the debug print, and at the same time I can see the memory structure, memory information of GDB. So here is now here is another way to run up the GDB and don't print out the debug information, don't print out the log in the monitor, and just output, redirect it into the output file. So here, this is how I solve this problem. So what will happen if I type this command in the GDB? First, it will run up the debug print function, but it will not show in the GDB monitor. It will redirect it into the file of the alt text file in the desktop, and it will still hit the breakpoint of cosine h in the GDB. So the GDB monitor will be the same part just like we have seen now, but we can go to see the debug print result in the out file. So now I show it to you. Okay, so we can see again, the GDB monitor is the same, but at the same time, we can go to see what is in the alt text. Nice. The process in the GDB is just stop at the breakpoint, but we can already see the debug result in the another file. So now we can debug it at the same time without the process exist. So I will try to access the memory in the GDB. Okay, it means that the process we can access to the memory and the process is still on the work. So now let us just try to see some elements in the elements of the memory structure in the object A. Okay, now you see something maybe like that B. To see this thing, you will start to think that, okay, this might be our the first element, which is also called that B. But I cannot find another element. So here I will talk about the memory structure of object in JavaScript. No, maybe I need to say that just V bar. Okay. So first, the object A to store the three elements is an object that have the three elements. So the first one, this means the value of the first element. Why will it show just like 2, 3, 3, 4, 9, 5, 5, 3, 4? It is because that wait a minute. if you just try to show what is this element, you will get the same result on it. So here the debug print just try to convert the hex into the decimal. So what is these three elements show about? So first, we will talk about how the V8 handle with the object memory. So first, in V8 will separate object to two types, which is called the first type is small integer, and for this type of element, it will just directly store it in the memory. So just like we have seen before in the GDB, we can just see the deadB in the memory. And the second type is called heap object. Be careful, this heap is not same as the heap which is allocated by the malloc. For the heap in the JS is very different from the heap in the C, the programming language C. This is very different memory segment. So now I will talk about how JS will handle these two type of element. So for first one, for the small integer, deadB, it will just directly store into the memory. And so in the JS object, there are a tag value that will both point to the small integer or the heap object. So then I go back to the result of debug print, this one. First, this one is the tag value that will point to the object of the JavaScript. So or maybe correct it. So this one, wait a minute, let me try to draw some picture. To point to the object in the JavaScript, the pointer bits will be the 8 bytes. So there will be the 64 bits in the operating system of x64. So here there will be a 64 bits pointer. However, not all of the 64 bits point to the address of the object. In fact, there is only 63 bits that will point to the address of the object, and 1 bit which work as the least signal bit that show some another object information, which I will not talk about it at here. So in fact, to point to the memory address of the object, there is only the first 63 bits. So if we want to print out the memory structure of the object, in fact, we always need to -1. So here, the first one will just show the element, and the second one means the length of the object, which is 3. The first one is that b. The second one is that beef. The third one is the string. So there is 3 elements. And then the third one is start with the elements. The first element is that bit, which is the small integer, and it will store integer which can store in the data type of the integer. And so I will take the example. What is difference between the data type of these two values? The first one can be stored in the integer, but the second one is the type of the double that cannot store in the data type of small integer. So for JavaScript, when it sees the first element which can be stored in a small integer, it will just directly store in the memory. So you can see here is that b. But the second one, which is that big, which is too big, that cannot store in the data type of the small integer. So now he need to use a type which is called heap number, which is one type of the heap object. So what will be the memory structure of the heap number, and what does this memory point, what does this memory address mean? So now I will introduce the memory structure of the heap number, just like that beef. For the type of heap number, there will be the pointer, again 63 bits and 1 bit of least significant bit, and this pointer will point to the address that first a byte of map offset, and the second 8 byte of first a byte will point to the map offset, and the second store the map offset, and the second second 8 byte will store the value of the heap number. So now I will demo to let you understand what I'm talking about this memory structure. Again, here pointer only use 63 bits to point to the real memory address, so we need to -1 again. This will be the pointer to the heap number of the second element. And we also need to -1 because it just used 63 bits to point to the place. So now this will be the map offset, and this will be the our second element, which is however, you cannot see the dead beef in this place because this is already the double number of the dead beef that JavaScript have already converted it into a double number. So you can also try to convert the double number to see whether it is the dead beef in hexamal format. So in next step, we will see the third element. The third element is the string, right? There is 8a. There is a which is multiplied with the 8 times. So maybe you have already forgot. It's okay. The third element here is a string of the a multiplied with 8 times. So what would be the memory structure of the string? Okay, again, for the string, it is also one type of the heap object. So for the string, there will also be a pointer which use only 63 bits and this significant bits for 1 bit. And then we'll point to the K-map offset, which will take 8 bytes, and the K hash, which also take for the 8 bytes. And then we can start to see our string value. In the first 8 byte, we can see from 0 to 8. And the second 8 byte, we can see continue from the okay. So this will also take 8 bytes. So now let us just make sure it in our GDB. First, just like I said, here is a pointer, and for the reason of we just only use the 63 bits to point to the place, so we need to -1. So again, oh, wrong one. -1. Okay, show it. Oh, now you can see that the first one is the 8 bytes of K-map offset, and the second one is here. The second one may be the 8 byte of K hash offset. I will not introduce what is K-map offset and K hash offset here because now it is important to show that we have already used GDB to see through the memory structure of JavaScript. And from the start of the third one, it is start to try to show the element of the string. So for the third element, it is a with 8 times. So here you can see a for 8 times, isn't it? And when I see this, I just shocked that why will there be a more a, because I just multiply a with 8 times. So maybe just be a coincidence. This is an address to point to another place. So we can try to see, is this a valid address? If it is an invalid address, it means that this 61 is still one part of my element. But if it is a valid address, it means that it is just the address point to another place, and it is a coincidence that it shows as 61. Okay, so this is a valid address. So now we just make sure that we can see the 8 for the 8 times. So, okay. Now we solve the problem, solve problem of setting break point in V8. Congratulations! And by the way, someone will use another way. Instead of the debug print, he will use just like this way to find, because you have already know that b is the type of small integer, so it will just directly store in the memory address. So we just need to use find b, and it will show just like this, and we can use this to find the address. So it will be same, but personally I am more prefer to see the result of the debug print, because just like showing the result, it has already shown the whole memory structure for you. And now we also have the method to set up the breakpoint. So I think this will be a good way to debug in the VA engine. So again, how do we solve this problem? Of course, we also show the result of debug print. We just need to run. Oh, the word is so big. Run up. With the file. Run up the file with the native function option, and at reset time, I also redirect the output of the debug print into another file. So I can see so now I can see some memory information in GDB, and also see the debug print result in the out file. So this is how I solve the problem, and I hope someone also interested in browser exploitation, or maybe someone also come across the problem of debugging can learn something from this video. So this is today's video what I want to share. Goodbye.